Hey guys, how you doing? I just learned something about long division that blew my mind. I didn't even know it existed. I consider myself a reasonably intelligent person when it comes to math, but this was something I didn't even know. Learned it from a colleague. I can't unlearn it. I don't know if I'll do long division a different way ever again. So let me show you what I'm talking about. How many times have you had a long division problem and you just go in and you multiply, you subtract, multiply and subtract, and you just keep going and you run out of paper because it's just going down. Sometimes you lose the place value. One number gets moved here or there, and you're like, oh my God, I'm out of time, I'm out of paper. I got a board that looks like this. I'm not even done with the problem, and I'm out of room. Well, this is a way to do the same problem, but instead of vertically up and down, we're going to solve this long division problem horizontally, going across, save ourselves a ton of space, not worrying about bringing numbers down in the right place. Let me show you what I'm talking about. So the long division problem we're going to do today is going to be 34,587. 34,587. And we're going to divide that by 7. Now, to do horizontal math, what I'm going to do instead of going down and drawing the traditional sign for division, I'm going to put this in a box. So I'm going to take my number, I'm going to put it in a giant box, just like that. And separate each number, just like this. Now, I'm going to do what I traditionally do. How many 7s can I put into a 3? 0. So donut, I'm going to pop a 0 up there. 0 times 7 is 0. I'm just going to put my subtraction right in this box. 3 take away 0 is 3. But now what I do is I take this 3, and I'm just going to move it over here next to the 4. Just like that. And now I got to say 7 goes into 34. How many times? Well, I know my 7 times tables, and that's going to be 4. So I'll put my 4 up top. 4 times 7 is 28. I'm going to put my 28 right in this little box here. Subtract. 34 take away 28 is 6. I'm going to take that 6. I'm going to pop it right over there. Okay? Now, 7 into 65, 9 times. 9 times 7 is 63. Same thing. I'm just going to sit here, subtract my 63. I got a 2. Take the 2, move it right over to the next column. Got a 2. 7 goes into 28 4 times. I'm going to put that 4 up top. 4 times 7 is 28. I'll subtract. I got a 0. Still got a number. So if I bring a 0 over here, well, it's still 7, and I know 7 goes into 7 one time. 1 times 7 is 7. I'm going to subtract. I got 0. I got no numbers. Done. 34,587 divided by 7 equals 4,941. Wow. Went right across the page, saved a whole bunch of space, didn't lose my place value, didn't worry about bringing down zeros, didn't worry about did I subtract, did I line it up properly, none of that. Traditional method, except everything goes in the box, move it over. Everything goes in the box, move it over. It's that easy. I just don't think I'll ever be able to do math again the same way, especially when it comes to my long division. In case you're wondering and you got some questions, if you ever end up having a remainder in a problem, well, your remainder's going to come here. You got no other numbers to put after the 7, so you know whatever's left in that last box after you subtract is going to be your remainder. Does this work with double digits? Absolutely. I can sit here and divide this by 14 instead, or divide it by any other 2-digit number, and the problem still works going all the way across. I suggest you give it a shot.